Okay, students, this is Mr. McCallum again, and we're going to work on question 13, and we're working on a logarithm transformation. So you have to first off remember what your basic logarithm equation looks like. And remember, I'll just give a quick little mini lesson about what we did in class with this. I know that I wasn't in class um, uh, for the past couple weeks, but we did go over graphing logarithms before I left. And when you have a logarithm, it's basically when you have like y equals log base 2 of x. That's basically the inverse plot of, um, you know, y equals, well, if I rewrite this if I rewrite this using exponentials, an exponential form of 2 to the y equals x, because remember base 2 raised to the y power equals x, and remember when you switch x and y, you get, 2 to the x equals y. So what the log base 2 function basically looks like is the mirror image of the exponential growth function. This is 2 to the x. Log base 2 looks like the mirror image across the line y equals x. We described this in class. And instead of being at 0, 1, your log function has the point 1 comma 0, and it is the mirror image of what the logarithm or what the exponential would look like. So I'm going to just draw, you know, for the, we had this asymptote for, the exponential graph. So now that for the exponential graph, which will be in red, that's the exponential function. The log base 2 function, which will all be in blue, I'll draw its asymptote. It has its asymptote at x equals 0. And it has a point 1 comma 0. And if the exponential had the point at like 2 comma 4, then the logarithm would have the point at 4 comma 2. So we described this in class, um, you know, uh, when we introduce logarithms, and I'm just going to write this as, this is log base 2 of x. So that being said, how we come up with a log function from exponential, you can just have on your note card, the parent function for any logarithm will basically look like this. It will look like, you have this asymptote at x equals 0, and you have a point running through 1 comma 0, and no matter what the logarithm is, log base b of x, right, it will always have this general appearance. So now they want us to do log base 2 of x plus 6, which is just, it's a leftward movement. Remember from our function transformations in the beginning of the year. A left movement, if you set x plus 6 equal to 0, you'll solve and find out that the function relocates to x equals -6. So that asymptote that was at x equals 0 is now at x. It's moved 6 to the right, to the left. So this is x equals -6. That point that was at 1 comma 0 has moved to -5 comma 0 because it's moved 6 to the left. And then the general shape of the function would appear, let me just draw that better. It's kind of awful. So I don't know if that's much better. Let me try one more time. Remember, I had surgery on my shoulder, so it's like kind of tough to draw with a sling on. So I'm going to just say that's good enough. That should connect. So anyway, hopefully not too many of you are graphing critics out there. And we have Desmos if you want to take a look at it further. I'm getting kind of crazy here, but that's the general shape or sketch of, oh yeah, remember it's a sketch. We're not, we just want to draw key points here. It's not a graph. We're just drawing a sketch to show how the log base 2 function is moved. So hopefully this has helped. It's been a good introduction, or not introduction, but a reminder of how we came up with the log function as the inverse. And, look forward to hearing your comments. Take care.